Hi and welcome to the hangar, where I will conduct my experiments using the Unreal Engine. This one is about synthesizing sound, more specifically, synthesizing the church bell sounds. So I started with modeling the mesh of the bell itself. I based it on a simple cylinder, and using the modeling mode in the Unreal Engine editor, I first made it hollow, added some more subdivisions so it bends nicely, and then using the lattice deform tool I just made it into a bell shape. And in the same fashion I created the hammer for the bell. As for the materials, in this prototyping phase I really like to use the starter content stuff, but this time nothing really did the trick, so I had to look elsewhere. I'm lucky enough to possess a great portion of the Megascans library, so I looked there. And indeed, after a bit of a search, I found a material that only needed to change some parameters and specifically the tint color, and it fits nicely. So now let's talk sound synthesis. I created this meta sound sample, and inside it I used just one sine wave oscillator. That's what we call a tone. When you add an envelope to this tone, which is just a fancy way of saying when you change the volume of the tone in time, then it starts sounding like something plucked or hit. Now if this is a tone, how come it doesn't sound like a guitar or piano or something like that? Well, there are not many, if any, natural oscillators that would oscillate in this simple sine wave fashion. Because of physics, natural oscillators usually produce a sound consisting of many frequencies. This set of frequencies we call a frequency content or frequency response or spectral content. And based on different frequency contents, we differentiate between the instruments. Lucky for us, this frequency response is pretty well measurable, so we have this handy table, and all we have to do to make a bell-like sound is to create as many sine wave oscillators as there is frequencies in this table. So that's what I did. Brace for impact. First bell ring is coming. I think that's not half bad for a first try. Now I do realize there is this additive oscillator node that can take array of frequencies, so you don't have to spawn a separate oscillator for each frequency. But when using that, all the frequencies will have the same envelope, so they will all die out at the same time, which is not how bell sounds, and it's not a problem for a short bell rings. But if you want the bell to go for 12-15 seconds, then it starts to be very noticeable. Yeah, those high frequencies needs to be silenced way sooner. That's why I'm keeping the oscillators separate, and I set a separate decay time for each frequency. Well, not perfect, but better. So the concept was proven, and I will now move those oscillators and envelopes into a meta sound patch, and I will reuse this patch, and it will make the graph a little bit more readable. and also the additional tuning a little bit easier. And there we go. I am pretty happy about this tone, so we can move to creating an actor using the geometry we created and the sound we just created. Now I do want for the sound to be impact triggered, so we will use collision between the hammer and the bell itself to trigger playing the sound. But hollow collisions are a big no-no in the Unreal Engine. So I will just use 2 box collisions, one on each side for the bell and 1 sphere collision for the hammer. I'm adding the meta sound source we just created with the bell sound as a component to my actor, and I will trigger the trigger whenever we receive a component hit event. From working on another project before, I have this simple, sharp, metallic hit sound, which I will now use for the hammer sound. Because the hammer must make some sound when impacting the bell as well. Right now, we're inside an audio volume which has a reverb. To be able to apply this reverb, first needed to create sound attenuation resource, set some basic things in there, and most importantly, assign this attenuation to the node that's playing the sound. Another thing I needed was a way to interact with the bell inside the game. For this, I will again recycle the system I had from before, which utilizes this simple interface that needs to be implemented on all clickables in the level, which is then called from the controller blueprint. By the way, I'm sorry for the controller blueprint code. I know it's terrible, but you know, it's work in progress. And the controller calls this interface on the clickable things in the level. So now the first playtest, yay! And it doesn't do anything. Maybe enabling the hit events would be a nice idea when we're using them to trigger the sound. Now that's what I'm talking about. Okay, obviously the hammer sound is way too loud. Otherwise, sounds alright to me. The movement of the bell didn't seem too natural, so I offset it a little bit and also created this counterweight to make the physics closer to the real world. And I think it worked. Another thing I wanted to implement was to make the volume of the sound depend on the strength of the hit. I didn't know what the exact numbers will be, so I just printed them and used those. And it did nothing because I didn't change the parameter names. Now it worked, but sounded terrible because the already playing sounds were immediately muted when the hammer hit with just a little bit of force, which I didn't like at all. So I decided to try the fire and forget approach, and instead of using triggers, I used play sound on location and achieved much better results for the time being. Happy with the result, I cleaned a little bit, moved the functionality into a function. And also did some more physics and design work on the bell itself. But then I really wanted for the player to be able to pull some rope or something to make the interaction more realistic and intuitive. First I tried to use the infamous cable component built in the Unreal Engine, but as usual it was a nightmare to set up and it was absolutely impossible to make the collisions right. I don't know why this is there, what's the use case for it. I have never managed to practically implement this component ever. So instead I resorted in creating my own skeletal rope. Let me know in the comments if you need a separate video on this, because it can be tricky but very useful. And after some initial collision problems, it worked like a charm. I did try to make the rope the thing that you pull with your mouse, but the results were mixed and I decided the effect is not worth all the fixing of the physics. I also played around with the angular damping values. It's funny that you can actually set negative values, which I use often, but when you set two negative values, it did take some playing around, but eventually I was happy with how the bell starts moving, how it moves and how it stops moving, so I could move on. Next step was another iteration over the design of the whole thing. And again, after resolving some physics and collisions, I was getting happy about how it looks like. Then using the Megascan materials again just sealed the deal, and I decided this is more than good enough for a prototype and was done with the design. One last thing was remaining, and that was to allow different sizes of bells and, accordingly, different tones. Obviously, the size was the easy part, and I thought the meta sound source is very well ready for the different tones, and it was. But turns out, when using the play sound at location, even though the sound source is a component of the actor, there is no way to set the initial parameters, so there's no way to change the fundamental frequency. And I tried desperately, and I mean desperately. I even switched to the trigger approach instead of the fire and forget. But it still had the hard re-trigger problem from before. So at the end, I resorted to just creating a separate meta sound source for each tone, which actually worked. And as it turned out much later, it's actually favorable to be able to tune each tone separately. So there we go, an unlimited amount of bells which make sound without any pre-recorded samples at all. Nice. Now, by no means did I stop there, but I feel like this video is way too long already. So let's stop it here and let me know in the comments. Would you like some more on this topic? Would you like to know how I made this carillon consisting of almost 60 bells at the end? Or was this enough of bells and should I explore something else? Definitely there is much more to come, so don't forget to subscribe. Please hit the like button if you like this video, it will help me a lot. And let me know what would you like to see next. Thanks for watching, see you again. Also, check out my other channel called Hanger Content, where I put, for now, songs played on those church bells.